Okay. Good evening, namaskar, and good morning and good afternoon, whichever part of the world you are. I am Ashok Garlapati and welcome you from J&A Bharat HSE Foundation and J&A Global HSE Foundation. We welcome you for this 22nd Outreach and Knowledge Transfer Session. Very important topic today. We are going to have it, which is the importance of ATEX certification for safe operations in explosive environments. Most of our participants today are working in the oil and gas industries, highly hazardous industries. So this particular topic is going to be very, very interesting to all of you. And if you are not yet shared with your friends, you can always share the link to your Zoom platform with your good friends. And with that, I would like to welcome you for this. And these are some of the virtual meetings protocols. On the right side bottom, you see the QR code. If you want to join and get our updates from time to time, just scan the QR code and you will be taken to the J&A WhatsApp group. So kindly mute your microphone and raise the hand whenever you want to speak. Switch off your camera and switch on when you want to speak. Post your queries, comments, suggestions in the chat box. And the meeting is being recorded for future reference. And please register your name, company, designation, phone, email ID in the chat box. And please stay for the ceremony group photo at the end of our part 1 of our session. It is going to be 2 parts. In fact, part 1 will be the J&A brief about the foundations and what we have got. And part 2 will be the technical topic. And in the part 1, we'll be briefing on our foundations and what exactly we do it. How can you collaborate with us to synergize our efforts? And part 2 will be our session on the ATEX certification for safe operations. We'll have Q&A, networking opportunities, and we'll also have the quiz by the HSE Champ platform. And most interesting thing is, top 3 winners will be given a gift as well. So thanks to Mr. Pravisha of HSE Champ. With that, I request our Mr. Jeetu Patel, our founding trustee, for his opening remarks. Mr. Jeetu.
Thank you, Ashok ji. Respected honored guest, and we start with our honored guest speaker, Mr. Tata Venkata Surya Prakasha, and many more distinguished.
Go ahead.
On behalf of the J&A Bharat and J&A Global HSE Foundation's governance and its 2 founding trustees, a very warm welcome to you all. I want to now take a minute to introduce one and only, whom everyone knows, my great friend and co-founding trustee, Ashok Garlapati ji. And talking about him, his contributions are remarkable globally, not only just within India and Middle East, but globally. He is now officially the president of BCSP, which stands for Board of Certified Safety Professional, and his duties will commence from January 1st, which is only in 3 days' time. And he's a fellow of the American Society of Safety Professionals, as well as fellow of IOSH, and many more feathers he has in his crown. So without wasting my time, your time, Ashok is a strong pillar of the foundation. And Ashok ji, I would request you to give a brief about our foundation, please.
Thank you, Jitsa, for the kind introduction. And without wasting much time, we would like to briefly provide some insight into our foundations. And me and Mr. Jeetu Patel, we have been together for many years, and together we have about 9 decades of experience in the HSE profession. We have been very actively supporting ASSP, which is American Society of Safety Professionals, as well as a BCSP for many years. And you see the blue flags there. We just made some sort of a influence or the footprints in those areas, supporting the HSE profession as well as the HSE professionals. And we wanted to do something more for India, and this is the ILO statistics. As you see, unfortunately, India is standing apart on the top of the graph with the highest number of global deaths related to the industrial accidents. And we wanted to give back to India with the knowledge which we are doing today. And also, we wanted to collaborate with Indian associations, Indian government, how we can support and bringing back to the global knowledge to the local level. With that in the intention of in our minds, we started this particular foundation called J&A Bharat HSE Foundation, which is launched on the 25th March 2022. Of course, it was online launching because of the COVID. And basically, we are collaborating with so many professional organizations, corporate organizations, academic institutions, individuals, as well as the philanthropists and NGOs. Individuals also, like we are collaborating with Mr. Prakash in sharing the knowledge. That's what we do it. Our mission, vision, and objectives are very, very simple: to support the HSE profession as well as the HSE professionals. So that is by different objectives. One is in advancing the profession among the industry, academic institutions, and organizations, to support and promote the HSC as a career choice among the students, to inspire and develop leaders, to provide educational and developmental opportunities, recognize individuals, organizations, academic institutions, as well as to conduct the HSC courses. Something interestingly we are going to announce today at the end of our session, some interesting courses coming up. And we'll also collaborate with the organizations who are having the similar objectives. And we do have our website. We are registered in India, and we have the professional development grant. We have the industrial accident victim family support grant. And we do have a student scholarship program sponsored by or supported by Madam Dhruti Thakkar from New Jersey. We provided the scholarship program for the 4 students during 2022, and also recently announced the 2023 recipients. And one of the recipients is from Chennai. Our J&A advocate, Mr. Dakshina Murthy, is going to visit the university tomorrow on behalf of J&A Bharat HSE Foundation. He is going to hand over this scholarship amount to Mr. Thangaraju, who is in Chennai. And we do have another program called the J&A Bharat HSE Foundation DL Shah Trust Awards Program, which was announced in Delhi almost 2 months back. And we also have the outreach knowledge sessions. We go to the colleges, universities. These are all the volunteers who are doing under the J&A platform, Professor Ramana, Dr. Lakshmi Narayan, on the first aid courses or the CPR programs. So many things are being happening. Again, we want individuals to contribute and support, not only in the financial form, as well as the knowledge sharing, which Mr. Prakash is doing today. If you go to our website, you will have the expression of interest form where you can fill up your information, and we'll reach out to you how you can collaborate. We do have a governance body as well as the different functional committee chair. Today we have the Mr. Funny, who is our knowledge transfer chair, also attending today. We would like to thank everybody who are listed here for supporting our activities. And in addition, we wanted to expand beyond India around the globe. So with that in mind, we started this Global HSE Foundation, which is registered in US under 501c, like Indian income tax ATG section. We do have in US 501c. Our foundation is registered there. And so that is also probably we are providing the information or support to across the globe. And as part of our foundation objectives, every month we do the knowledge transfer sessions. And this is one of the knowledge transfer session, which is a 22nd knowledge transfer session. And In fact, Mr. Carl Heinlein, who is participating today, he was also one of the subject matter expert presented in our OKT sessions. So today we have invited Mr. Tata Surya Prakash. He is also subject matter expert, and he is a qualified chemical engineer with 26 plus years of experience. Very, very good, 2 decades plus experience. He's a certified lead auditor for 9001, 14001, 45001, and also focusing on the management system to achieve the zero harm. Effective project management for loss prevention, process safety design, and process safety management assurance from feed to the completions through detail engineering, construction, and commissioning. He's a self-published author of the fiction, non-fiction, and technical books. He works with us in Kuwait, and we would like to thank him very much for accepting our request and sharing his knowledge. He is also our J&A WhatsApp group ambassador. We do have a very active WhatsApp group. And if anybody asks a question, he's the first one. He's one among the first one to share his knowledge and to provide the right direction. Today, we are going to have his session on the ATEX certifications for the safe operations. He's going to talk about the introduction on the explosive atmosphere, some of the case studies, incidents, and importance of the ATEX certification for safe operations, ATEX equivalent certification standards in India. Of course, we'll have a question and answer session. So as advised by Mr. Jeetu, before we go to the part 2 of our technical session, before we hand over, I'm going to unscreen, and I request you to open your camera so that we'll have a clear picture of all of us today before we hand over to Mr. Surya Prakash. So kindly, yes, please open your camera so that we can take a nice picture of you guys. Very much required. Everybody, yes. 1, 2, 3. Good, excellent. We have almost 25 plus people. That's very nice. So great, excellent. I'm counting down. 5, 4, 3, 2, 1. Good. Very nice. Thank you. And I'm sharing Mr. Prakash's presentation. I will also invite him for our brief introduction about him, if I missed anything. And handing over to Mr. Prakash. Please go ahead, sir.
A very good evening to all from Kuwait, and somebody it's the morning, and somebody maybe it is very late in the night maybe. So I wish all of them a nice day wherever they are. And first of all, I will be very thankful to Ashok ji for considering me to take up this OKT session with the J&A Foundation, because the foundation's principles with which it was started to help the HSE professionals has been very innovative and interesting to me. And I am with Ashok ji for almost more than 2 decades in Kuwait, and we shared a lot of great moments, and we learned a lot from the mentors like him and Jitu ji, and so many people in J&A Foundation, as well as with the ASSP, and working together in Kuwait. So it's very thank you very much to you all. And today I am talking about the ATEX, explosive atmospheres requirements globally, and in the context of Indian manufacturers who are going to be supplying the equipment and designing or manufacturing, or the workers who are working globally for many organizations, to know basic things about how the ATEX guidelines works in European Union, and how it works in the US, as well as how we should be ready ourselves to take up this. First, let us go through the requirements. So I will take you quickly through the background of ATEX. So explosive atmosphere can be caused by any flammable gases, or mists, or vapors, or by combustible dusts. If there is enough amount of substance is there, and if it mixes with the air, so all it needs is just a simple source of ignition, either it is from this hot surface, from an electrical source, or anything. Then it leads to major explosion, and then it subsequently leading to fatalities and loss of life, as well as the asset losses, etc., as we have seen in many accidents over a period of time in the last decade or two, or even more before. Explosions can cause loss of life and serious injuries, as well as significant damages. Preventing release of dangerous substances which can create explosive atmospheres and preventing sources of ignition are two widely used ways of reducing the risk. So as we are all the being risk provisions, what we will do is we have to first thing we try to eliminating of the dangerous substances, as well as eliminating the ignition sources. These are our primary ways of managing risks to prevent the major accident hazards at workplaces. So the ATEX and dangerous substance exposure atmosphere regulations place duties on employers to eliminate or control the risks from explosive atmospheres in the workplace. See, primarily the ATEX as well as the dossier of the UK puts the onus of responsibility on the employers. Basically, as any safety management system says, the safe work environment creation is the responsibility of an employer. So by default, so the explosive environments protection requirements development is also the responsibility of the employer. So now let us know about what is an explosive atmosphere. So this is nothing but a mixture of dangerous substances with air under atmospheric conditions. Even in normal temperature pressure operating conditions also, an explosive material environment can develop in the form of either it is in the gases or in the form of vapor mists or dust, or after and when an ignition occurred, combustion spreads to entire uncombustible mixture. So atmospheric conditions are commonly referred to an ambient temperature and pressures. This is to say the temperature is from the minus 20 degrees to 40 degrees, or the pressure from 0 to 1.1 bar also will lead to this explosive atmosphere clearation. So these atmospheres generally we will found in many places where we produce explosive and potentially explosive atmospheres. Examples include places where work activities create or release flammable gases or vapors, such as vehicles, paint spraying areas, or in workplaces where we are at oil and gas working environments, handling of fires and organics, and dust from the power plants. There is a coal dust will be generated. Even iron ore dust from the iron mining industry also can generate a substantial amount of dust, which may lead to create an explosive atmosphere. And upon provision of an ignition source or availability of ignition source, it can explode and lead to cause of loss of life. And so even the agriculture sector or food manufacturing sector, like grains or flour, a fine flour is also a dangerous explosive atmosphere. It can be created there, or a wood dust in the saw industry, etc. So next slide we will go.
Yeah.
So the ATEX is the name commonly given to the two European directives. One is 992 EC, which is ATEX 137, and minimum requirements for improving the health and safety protection of workers potentially at risk from explosive atmospheres. And the directive, again, 2014, it was issued ATEX 114, which is also for the laws of member states concerning equipments and protective systems intended for use in potentially explosive atmospheres. So we will go through the history of ATEX. The ATEX regulation is based on the European directives. Directive is started right back in 1999 on minimum requirements for improving the safety and health protection of workers potentially at risk from the explosive atmospheres. So the directive first came into implementation in 1919 with the lone purpose of protecting workers who are working in the explosive environments. Then in 1994, it was first been floated up, and concerning equipments and protective systems, how they have to be designed, because workers are prone to expose to worker environment. So equipment also should meet certain criteria while it was placed in an atmosphere where explosion can happen. So in 2003, it was first been given ATEX directive mandated applicable for the whole European community, and all companies which are concerned by the manufacturing, the use of the distribution of equipments intended to be put into service in explosive atmospheres will have the condition you have to conform to the essential requirements with regard to safety and health which are envisaged by the ATEX directions. So this is the main ATEX motive. So even equipment what we are going to use, everything should comply with the latest requirements. Then we will go to next slide. So what are the obligations for the manufacturers? Here we will discuss about the manufacturer obligations. So all the new equipments for use in explosive atmospheres can only be marketed if they are perfectly in conformity with the requirements of the ATEX regulation. Consequently, these equipments will have to carry the ATEX standardized marking on their marking plates. So that is a very important requirement of the ATEX. These each and equipment that has been manufactured shall be marked properly as per the harmonized manufacturer's guidance. According to it has to be marked properly. So the obligations for the users is to take technical or organizational means adapted with the type of exploitation, to evaluate the risk of explosion on the overall basis, to subdivide in zones the sites where explosive atmospheres can arise, to see up a visible indication of the defined zones. Primarily the user has to define this equipment's his ATEX rating has been supplied, so they have to identify the zones, explosive zones. Accordingly, all the mitigation steps has to be taken up. So in the what is explosion? We wanted to know first before we are going in detail about ATEX guidelines. An explosion is the fast evolution of a system with release of energy and production of mechanical and possibly thermal effects, serious human and material damage, important formation of gas and heat. It is very important to know what is explosion is. So what is an explosive atmosphere? As we call, ATEX is nothing but the explosive atmosphere is an atmosphere which could become explosive because of the local and operational conditions. It is a mixture of air and a flammable substance in the form of gas, vapor, fog, or dust, in which after ignition is been supplied to it, the combustion is propagated to the whole of the mixture which has not been burned yet. So this is what the explosive atmosphere is called. So ignition source, we all know, a sufficiently important source of energy. It may be a mechanical energy caused by the friction, or an electrical spark, or an electrostatic discharge from us, or a naked flame which may lead to the work as an ignition source, or a lightning. We have seen many incidents. Even one major incident happened in US also due to lightning. A complete tank farm, because there is no lightning protection is there, and tank caught fire, and subsequently it went to a disastrous incident. A sufficiently high temperature or hot surface also an ignition source. So what is the case of an explosion? To be explosive, the gas mixture shall be either too poor or too rich in flammable substances. So we all heard about LLE, or lower limit of explosion, or LEL, and the concentration of flammable substances in there, and upper limits. For example, if you take the hydrogen, we will always say lower limit is 4.5 and upper limit up to 75%. That means in that range, the flammable substance will form. So each and every substance will have that. So this kind of service that you are going to use, the equipment when you are designing, you have to take all these things into consideration when you are preparing the explosion, when you are manufacturing an equipment for the use in this explosive atmosphere or explosive environment. So then the temperature of the flammable liquid shall be sufficiently high to form enough vapors. So temperature is always, if it is greater than flash point, so it will happen. So whenever the temperature is greater than the flash point, it will tend to release a subsequent quantity of vapors, which it in turn tends to create an explosive environment, and then it will lead to subsequently the explosion. Combustible dust layers or clouds with mix of air and combustible dust can be very explosive in nature. So surface temperature of the process should be always the greater than the self-ignition temperature to cause an vapor explosion case. So in the next slide, we are going to discuss what are different substances tend to cause explosions. So we have seen different kinds of, substances. For example, gases. We are working in oil and gas industry. We know about methane, natural gas main component, and butane, propane, and now we are switching over to hydrogen for our climate change requirements, which is having a catastrophic explosion and fire because of this over pressure, and it's very lighter in air nature. So these are all new hazards will be coming. And vapors like ethyl carbon or carbon bisulfide or acetone or oxides of ethylene, and dusts, for example, aluminum dust will cause a major explosion, and cereals and coal dust, which is also all explosive, and starch, and even the most Birat, over a period of time, we all remember, see the ammonium nitrate dust explosion environment is created, and it leads subsequently a major, explosion happened, causing havoc there in the Birat. So starting from Opavo to Birat, the ammonium nitrate explosions are very, very catastrophic. We have remembered these are all mostly caused by the dust and fertilizer dust that we can call. So these are all, we are all working in different many industries like petroleum, chemical, and oil and gas, downstream and upstream industries are always prone to have these gaseous as well as vaporous environments, because the process itself is prone to these things. So we have to be very, even like pesticide manufacturing organizations also use different toxicological chemicals, and as well as the flammable and combustible chemicals being used there. So they will also cause, and recycling industries also prone to provide a substantial amount of these vapors, gases, or dusts to lead to an explosion. So then next slide, we are going to look about ATEX classification. So this classification of zones is very important to understand, as the gases and the gas atmosphere and dust atmosphere are two areas where the classification, ATEX classification works on. For example, presence of an explosive atmosphere, permanent presence under normal operations, or we regularly we will use when you are doing the hazardous area classification. Zone 0 is permanently the atmosphere is present, where the explosive environment is present is called zone 0, and that for the dust it is called zone 20. So for occasional presence under normal operation, it is called zone 1, and it is under for dust it is called zone 21. So the accidental presence are made very now and then, or rarely presence is there, it is called the zone of 2, and the dust for dust it is zone considered as 22. So equipment categorization is based on the zones. For example, to recognize the zones where the apparatus or equipment can be installed, they are split into two major fields, mines and surface, and classified with the following categories. For example, category of apparatus in surface is called 1, means when it goes to mines, it is called M1. And suitable zones, we call it then, as per the above explanation, zone 0 or zone 20 we will consider. For example, if the surface is taken as 2, and in the mines it is considered as M2, and in the suitable zones it is called zone 1 or zone 21. Like this, many zones were listed, so each one has been given. So for three, for example, suitable zones are zone 2, that are the zone number 22. Like this, it will take. So minimum source of ignition energy for gas groups, we will quickly look into this one. So 4 groups of gas are defined based on characteristics of 5 representative gases. The one used for the type test is, for example, equipment type or apparatus group. Group 1 for mines, for example, it is called a gas group 1, and methane is the gas which is present there. And minimum source of energy for the methane to create an explosive environment is 300 mega for this one. And group 2 surface is, for example, 2A, 2B, and 2C is there. For example, these gases are propane, ethylene, acetylene, and hydrogen. So their ignition energies are given around approximately, as given there, 240, 70, 17, and 17. So different temperature classes also been given there. For example, T1 class is above corresponding surface temperature should be 450 degrees, and the T2 class is 300 degrees centigrade, and for the T3 it is 200, and for T4 it is 135, and for T5 it is 100, and T6 is 85. Why the surface temperature classes and these different classes have been given? Because the equipment designer or manufacturer has to design his equipment to sustain these surface temperatures before an explosion take place, leading to a catastrophic incident. So these are all design requirements based on which he should establish his own quality control and quality assurance plan to meet, like some excels required post-well heat treatment to sustain the surface temperatures, or once we generally rules set for the vessels, for example, as per the boiler pressure vessels code, a post-weld heat treatment vessel shall not be welded once it is been completed. That means this its conditions will vary if it is allowed to weld. So even nozzles and all has to be locations, everything has to be freezed before, and the design itself has to take care, and this cannot be done. So even from the vessel manufacturer in some other country, say, and the vessel end user is in some other country, and installation team will come, construction team will come. So these all things need to be properly documented and evaluated and certified and notified to everyone, so that we will not compromise with the requirements of the codes and standards to avoid this explosion environment creation or explosive incidents. So mostly world globally, we are at a risk of aging plants hazards, because most of the plants are aged, but because of the cost implications, the life has been extended. Hence, the assessment of the aging plant life, evaluation and extension standards need to be established, and these guidelines, ATEX guidelines, will play a very vital role in those practices. So now we will go to classification of gas and dusters, for example. I will not read all of them because this has been a big list of this, but the gases, 4 groups of gases are defined, and based on characteristic 5 representative gases, the ones uses for the type of test, for example. So as we discussed in the previous slide, based on the corresponding temperature, surface temperature, and the classification, for example, acetone A is there, so it is classified as a 2A class, and corresponding temperature class is T1, which has been given. Similarly, for dust cases, if you see, for example, if you are a flour mill, if it is a food processing industry, what will be the hazard? No, there is a hazard because it is having a cloud formation. Temperature is a 490 degrees, and it has the layer formation is 340 degrees. So if the 340 degrees temperature, it is possible that there is a layer, so a flammable layer will be formed, and it will lead to explosion. So like this soot is there, for example, is a cloud is at 810 degrees temperatures, and the layer will form at 570 degrees. So these are all the guidelines. So accordingly, not only the operating conditions of the equipment, also its operability as well as management of this during different working conditions also taken place during the design as well as operational stages of the projects. So equivalencies between US and CE markings, we will just quickly go through it. For example, so equipment or apparatus group 1 is, for example, if it is mines, so it is called a gas group CE1, and group 2, if you say CAS US, it is called a mines group, and representative gas is, for example, it is a methane is considered like that. And group 2 surfaces, for example, 2A, 2B, or 2B plus H2, and etc. is given there. So this is the D class at division 1/2, or 2 class 2A with zone 0, 0, 1, 1 or 2. So like this it was given. So there is equivalencies between the European as well as the US equivalencies. Accordingly, the manufacturer should take into consideration, and while the is marking his equipment, he has to take care of these compliance requirements. So for example, if you know classification zones, as it was mentioned, zone 0 or zone 20 for gas and 20, or zone 1 or zone 21 for gas and dust, it was given no accidental presence. In case of dysfunction, it is zone 2, and zone 22 is given. So like this it is there. And in the case of CSA US, it is a class is given, class, division, class 2, class, zone 0, etc. is given. So more or less it is the conditions of manufacturing, everything may be same, but in the marking he has to take, as well as some testing and certification requirements may vary based on the country to country and based on national regulations. So the manufacturer or the end user has to be in coordination to understand, comply with the requirements. So now, how we can prevent explosions? This we wanted to know, because the ethics regulations and all are there to avoid creation of an explosive environment. So the criteria of explosion prevention is basically preventing the formation of an explosive atmosphere is primary step. So if you prevent the formation of explosive atmosphere itself, That means you are eliminating the hazard itself. So, are the preventing the effectiveness of ignition sources. The second is even the explosive atmosphere is formed, but if you don't supply an ignition source within the vicinity of the zone, so then you are avoiding the explosion. So, first one is the eliminating the hazard itself, that don't create an explosive atmosphere. In the second one is to eliminating the ignition source which lead to the explosion. And the third one is propagation of ignition, which we should forward for is expansion or propagation of the ignition shall be curtailed through the active, passive, or protective measures where whatever applicable. So equipment compliance, only the equipments which are approved for the ATEX can be used in explosive atmospheres because they have the some extra sustainability or fire rating, we will call it, 6-hour fire rated equipment shall be used in oil and gas environment. Mostly we will see. So because it is that equipment is designed to sustain in the worst case of explosion or fire also. So that is how we design will take care of all these things. The compliance with ATEX can be evaluated by an ATEX notified body or can be self-evaluatory by the manufacturer depending on the belonging category of the operators. It is each equipment falls under some categories based on the codes and standards applicable. So manufacturer is fully responsible as well as the end user and manufacturer are responsible for ensuring that certification requirement identification and certification assurance. So this is very important part of the category. For example, electrical equipment, if you see equipments, category is 1 or M1, it will call certification by notified body required. It is a Mr. conformity assessment. So involved agencies of direct to, as per this one is 3 and 4 or 5 or 9, etc. It was given. So each code as this given, there are approved bodies from the ATEX or regulators. So those only can certify that particular equipment as mentioned in the directive. So for example, if you class 3, 4 or 5 or 6, 9 is there. So if you have to go for that, whatever the approved certification bodies, only you can go and you can get them certified. Similarly, it was given for all mechanical equipments, also given a certification by notified body required. So as the codes mentioned, they're involved in this, you have to go for this. And for example, the mechanical equipment category 3, if it is there, self-certification or voluntary certification by a notified body. So there in that there is an option is given self-certification. That means the manufacturer is an ISO certified organization and it is having its own patented manufacturing system. So it can certify itself. Like the many vessel manufacturers having their own self-certification body, and sometimes the end user may ask for the third party, but this can be acceptable as per the directives given. So the different types of protection we will see for the electrical apparatus, for the gas and dust, we will see here, for example, because I will not take you through all the listings here, but some important ones I will take. It's, for example, intrinsic safety. If we talk about intrinsically safe things, we are always asking about this should be intrinsically safe or explosion resistant, etc. Like IP rated, only instrument cables or instruments or electrical equipment shall be used like that. We will capture in the data sheets during the design. That means no spark or no thermal effect due to the choice of the components and the limitations of energy taking into account two faults. So that is based on routings and seal ratings. We will see that at no point of time there will be two faults happen simultaneously. So that should be designed for the intrinsic safety. Similarly, if you get encapsulation, for example, all components conceptualized in the resin, for example, or for example, powder filling, all components protected by an enclosure full of filling material. So we will use the filling material for the powder filling so that it cannot create an atmosphere. For example, for the dust, if you see, for example, type of protection, components protected by an enclosure which is pressurized with a protective gas at higher pressure than the atmosphere. So that is a type of protection so that we can avoid that dust explosion environment formation, subsequently leading to the explosion. Similarly, for example, mechanical apparatus for the gas and dust, if you see, flow restricting enclosures, generally we recommend for restriction of flow inside the enclosure itself so that the explosive environment externally will not form and it is contained internally. So that is the one way of the, and flame proof enclosures, we will recommend enclosures which can withstand an explosion and prevent its propagation. So these are the different way of types of protections that we will recommend for each equipment or apparatus that is been used in explosive atmospheres environments. So the overview, our types of protection, for example, ingression protection codes were given. For example, here, if you see non-protected means the index is 0. So it means second figure protection against water penetration. For example, it is non-protected. For example, wire of 1 mm dust tight is there means it is given as an index number as 6 in the ATEX category. For example, it is follows index as 6, 7, and 8. For example, it is falling under 6 means powerful jets of water from any direction will be formed. That is like, deluge systems or other systems. And say for next one is immersion is a protection things, or we use penetration, water penetration, and the continuous immersion to prevent the further exaggeration of the explosion or fire. So the marking guidelines, I will try to take you through here quickly. So this is the very important part in this ATEX guidelines as required. So the CE marking is a very important place where it is the way it was shown there. The marking is first one is like, CE marking, it will be mentioned. Then the 035 number of notified body, which has checked the production quality. As we discussed earlier, there is 3 layers of certification, like self-certification and third-party certification, etc. So what kind of certification body involved in the certification, and the logo with that is what kind of explosive atmosphere it is. First we were seeing 2 kinds of EX explosive logos. No, similarly that kind of logo has to be pasted there. And group of apparatus to surface, for example, which group it falls, as we shown earlier. So group 2 or group 1 or group 3A, whatever the group it belongs to. And the next category of the apparatus we have to see. So what kind of apparatus, as we discussed earlier, no, the group category also we have to take into consideration. And then it is for the gas or dust, whatever it may be, we have to, I mentioned that one. This equipment is designed for a gas environment, explosive environment. This equipment is designed for a dust explosive environment, like this. So then we have the notification, like as we told, E is for answer to European SINLEC standards, or EXD is there. And the types of protection, that is D class is the small d is given there. So that is the type of protection required. And the group is gas group, it is 2C is given. And the temperature class also should be mentioned. So that means when it mentioned a temperature 6, means that temperature class 6, for example, in the class of 85 degrees or maybe 100 degrees. So when the operators know that this is designed for this temperature, so it should not exceed the temperature. So accordingly we will design the temperature process conditions to meet those requirements. So these are all very important for us. And also ingress protection, IP protection requirements against the solids and liquids, whatever that IP66, IP65 or IP90, different ingress protection requirements are mentioned. Accordingly the design will follow. So this enclosure is required for IP60, IP65 product, IP66 protected, or different means. So for example, instrument cables supplied for an equipment in this area is electrical cables or electrical switches are source of ignition. So what we will do in that case, if the IP protection is required, means those should be inside an explosion proof enclosures, and they should not lead to an explosion ignition. There should not be an ignition source for the equipment in the worst case scenario when an explosive atmosphere is developed, but we are preventing the ignition source. Like that, this will help us, so that the design, safety in design will take all these into consideration while designing, as well as while operations also, as per based on these conditions, operations and control systems also will follow these design requirements. So this marking guidelines, as I shown you, this is the typical ATEX and ICEX marking ATEX. So complies with European directives, and specific that's signal what is given is specific marking for explosion protection requirements. Like notified body number is given there. For example, 359, maybe some international body which was approved, like you under UL laboratory or Lloyd's or SGS, or many organizations are there which were certified for these certifications. So the manufacturer, if it is a third party requirement is there, he has to approach and it has to follow the guidelines. They have to ensure that the certificate requirements, production process followed the requirements of the certification, like post-quality treatment, before that all requirements identified. Then during the inspection, like quality control and quality assurance practices after the equipment installed. If it is a post-weld heat treatment vessel, means there's no welding is been allowed in this. These are all quality control practices requirements. So this marking is not just a marking for marketing purpose, it is a guide for your protection there. For example, if you have these markings understanding properly by the worker, operators or the designers, engineers, etc. They should understand these markings properly, so that accordingly they can design their safety systems to protect the people and protect the asset, as well as prevent the environmental damage. So this is the sample certification. This is a self-certification certificate where these quality control people will use what is to be checked. For example, the electrical system has been designed in accordance with the requirements of as I told you, IP rating is there. So the system has to be according to it. For example, it is not about the cable quality itself, but how the cable has to be, how the switch has to be placed, where, how the switch enclosure to be there. These are all will be given based on the equipment functioning and subsequent fire zones. So accordingly, the zones are identified. Then accordingly, it will be designed. So this is a simple checklist for the self-certification checklist. So the manufacturer himself will use if it is authenticated to certify himself, or the third party also will verify his own certification process. So these all checklists through a checklist or the verification process will be there. Accordingly, they will do it. The lightning and surge protection has been designed in accordance with the requirements of the different standards, as IS standard is there, EN standard is there, codes are there. Different countries will use their own regulations, or ISO standards also there. So these things will be the yes or no, or like a checklist, but it is done according to the requirements. So equipment selection is in accordance with the requirements, and ATEX related functional safety systems have been incorporated into the design. This functional safety will play a very critical role as far as ATEX is concerned, because based on that, equipment protection deals with the different exceptional functional safety requirements identification. So that is very critical part in this. Like project side we will do SIL studies. The SIL studies will follow two stages. One is a assessment stage. We will as a determination stage. Then verification is done by the approved agency through using the approved certification body. So each and equipment will be SIL rated certified. We will get it. That means that particular equipment is certified for that particular functional safety requirements rating. So that certification has to be obtained. So these are all the things which has to be ensured while performing these, while manufacturing or using these ATEX rated equipments and ATEX rated requirements. So descriptive system documentations used, and hazardous area classification also based on these equipments design and rates. So we will have every facility that we are working where is having an hazardous area classification. That is the your quick guide to plan your emergency response. For example, hazardous area in one facility also there are different hazardous area classifications were there. Different fire zones will be given. The purpose of this is to which area, if anything happens, how to isolate that particular system or particular area only to limit the impact. So that will give you an immediate guide to plan your emergency response, to prevent the damage or catastrophe, to a small incident exaggerating into a catastrophe. These will help you to guide and protect your systems and processes. The required frequency of ATEX inspections is documented and forms part of handover. The vessel is manufactured. Generally, vessels will have long duration time, but periodically these vessels or ATEX rated equipment apparatus need to be inspected, because corrosion design time, corrosion allowances, etc. will be followed certain area, but based on the operational conditions, maybe the exaggerated corrosion may lead to the damage to the equipment. So periodical inspections are very important. And that is a predictive maintenance as well as a product preventive maintenance practices as per the ATEX requirements need to be conducted on each vessels, conducted by a approved vessel. For example, API vessels should be having an API certified vessel. Vessel inspector has to conduct, and that there is certain criteria to do it, and 100% thickness need to be tested, like, pressure testing has to be done again, etc. Guidelines are there. These should not be skipped, because in the end, the effective functioning of a vessel or system is deals with the life of people who are working in the vicinity of the zone. So when we are doing risk assessments quantitatively, we always take the people affected. in that area. For example, manpower or operator, how much people will be there. Then we will calculate, PLL, etc. We will calculate loss of life, potential loss of life possibilities. Because in the end, we value life. We don't want anybody to be get injured or loss his life, because everybody work to live, not to die. So that is very important for us. So it is very important that the atmosphere created is safe enough for every worker, and the responsibility of creating a safe work environment is in the end lies with the employer. So he has to take the call on complaints with either ATEX or any other applicable guidelines, and he has to ensure. So as we discussed earlier, also just this manufacturer certification, that is called self-certification. Also, it has a standard format, so he has to follow. He has to mention all the details of it, and the supporting evidence has to be attached, and that each and every equipment shall be supplied with the manufacturer certification. This thing, and the third-party certification, as I told you before, there are many organizations are there, so which will certify is a mandatory requirement in the most of the European Union countries. ISO certified organizations which are having a effective quality management system. In the basic criteria of an ISO 9001 is the quality management system is independent of the process or design or other thing. That means this integrity has to be ensured. So that's why it is always like, independent. It will even within the organization, the quality control and HSE teams work as independently. That means the reporting levels will differ from that of the rest of the bodies. The main motive is that to prevent influence on them, because their decision making shall not be influenced by, for example, design team is designing. There is a quality assurance team is there. Quality assurance team will not report to the design manager. They will report to the manager above them. This is why the main motive, if this is, there should not be any compromise in the process of assessments. So that is the way. That is why this the robust documentation as well as inspection quality assurance process follow these practices to meet the requirements. So there are some ATEX guidelines exclusions also there. So which were like, for example, medical devices will not fall under ATEX guidelines requirements, and products for use in the presence of explosives and products of domestic use are not fall under this one, and personal protective equipment will not fall under ATEX guidelines requirements, and seasoning vessels and mobile of offshore units. They were seagoing and vessels and mobile offshore units. They will not fall under the ATEX requirements. And means of transport except vehicles for use in potentially explosive atmospheres and some military equipments. These are all not fall under the ATEX requirements guidelines. And thank you very much. With this, I will conclude.
Thank you, Prakash ji, and we will not allow you to conclude because we have a very important Q&A session. I see a lot of questions around there. Okay, so let me on screen now. Then let me go back to my presentation. And yes, we welcome our 1 minute. Let me introduce our Q&A moderator today. Mr. Jitu, would you like to introduce, or you want me to introduce?
Go ahead, Ashok ji.
Okay. So, yeah, Mr. Our today's, yes, it is changing, yeah, Q&A session. Our moderator is Mr. Funny. He is our J&A chair for the HSE Knowledge Cell. And his expertise in safety-related issues and developing and implementing safety management system. And he is a right man for taking the Q&A moderation. As you see on the screen, he is expert in so many standards as well as HAZOP and PSM, NFPA, FAST, and so many things he has got into his arena. He worked in several types of industries. He holds a master's in industrial safety engineering, bachelor's in electrical and electronics engineering. He is also ASP from DCSP, and about general certificate, and so many things in place. We welcome Mr. Fani ji for taking up this role. Mr. Fani, please go ahead. Yeah.
Thank you very much. I think I'm loud and clear.
Yes, you are loud and clear. Yeah.
Okay. So, Prakash ji, thank you. It was a very wonderful session, and without any delay, we will quickly enter into our Q&A session. We got some queries from our participants. So, the first question is from Mr. Harikumar. He is asking to describe in detail about the static discharge possibilities for explosion and ATEX equipment requirements. I would, Prakash ji can respond to that question.
Are you on the mute? Or
Yeah.
something? Yeah, go ahead. Yes.
Yes, static discharge always is in a consideration, but mostly when it comes to the equipments rated for attacks, the grounding and earthing requirements are very stringent. So the static discharge may not lead to that explosion environment, but the grounding and earthing requirements will mitigate this static discharge related issues in the ATEX equipments, especially ATEX rate requirements. Required equipments will comply with those things, because this as I told you, from the manufacturer to end user, everything will be defined. For example, manufacturer will only manufacture the vessel is manufactured by, for example, an ABB or L&T in India. So they will give the vessel, but the instrumentation will come from somebody. The control system will be from some Emerson. So these are all having a set of requirements to be fulfilled to prevent this, like lightning protection requirements will be there, for example. Similarly, the static discharge, the overall in a plant, you will have a very robust grounding and earthing requirements for all the equipments. So that will mitigate the static discharge. So mostly, so that will not be a major issue. But this has to be complied. This is a part of the design requirements itself. Grounding and earthing requirement will address this one.
Okay. And the next question is from Mohammed Shoaib. What is arc flash? Is it considered as ATEX?
Arc flash, basically we will see in the high voltage substations, and then arc flash study will be considered there. So that is a separate study is conducted for each substations, whereas the arc flash from the equipments or vessels is not that possible this thing. But in substations, yes, it is very much important. And substations, basically they will follow different electrical categorization, classification will be there. So like arc flash study is mandatory in the each substation design. And then we will have this unmanned energy and protection system. Unmanned, most of the substations where arc flash is envisaged, so there will be a mandatory requirement for energy and fire suppression system, etc., based on latest experiences. So these are will address. So arc flash for the equipments may not be applicable there, but the electrical classification zone will address that one. But arc flashes mostly will be seen in the substations where this is a major hazard. So there the prevention measures, substation design will take care into that one. So electrical equipments will fall into the classifications based on the requirements also.
Okay. So next question is from Mr. Balu Mahesh Reddy. Is it included hazard area classification part of ATEX? I think this question is cleared from the session itself, Mr. Balu.
Yes.
So it is clearly understood that once you conduct hazard area classification, then you will understand the clear requirements of the electrical equipments, which classification equipments should you be using there. So that is cleared as part of the session. So the next question is from Mr. Guru Pratap. He's asking to explain ATEX requirements, especially actions in India that we need to take in case of hydrogen gas atmosphere. Can you shed some light on this hydrogen gas atmosphere? Because this is very much seen in as part of hydrogenation section in pharma industries.
Hydrogenation sections in pharma industries, but hydrogen is not new to us. We are, it is a very, we are into in India. Fertilizers mostly manufactured from naphtha or natural gas. Mostly for hydrogen reforming is always there. So the steam methane reforming is having a standard process, and that is a primary reforming, secondary reforming, and then hydrogen production and methanation. These are standard practices are there, and uh, design is very robust in that. So when it comes to distribution, yes, it's a fuel or fuel cell category. We were getting into it, And there are robust requirements. We can take a full session on hydrogen safety requirements in future. So based on time availability, so that we will understand that one. Not about hydrogen production, but hydrogen as a fuel or as an alternative fuel cell manufacturing to as a substitute to the existing fossil fuels, which is going to happen in at next decade. So that we can discuss. But hydrogen major problem is it is not an toxic, but it is having a very high detonation and explosion properties. So it is lighter than air. So as long as you leave it to go to atmosphere, no harm. But the moment it is obstructed in a particular area within a short span of time, 4.5% retreatment, it explodes. So that is the major danger of it. And so hydrogen vent design is very critical, whether it is in the distribution area or hydrogen gas environments. The design of the vent system is very robust. There are
But
many
if it
guidelines
is
already been there by CGA, everything. So we will discuss in detail next time. But this is hydrogen is having a different set of hazards compared to
so
others.
I just want to quickly check on the electrical part. I mean, if we go to classification section, so how do we choose this electrical equipments if such a flammable atmosphere is there? Hydrogen gas. I know that we have gone through the slide, but if you can just connect that to that slide and say, okay, this is the requirement if you need to fulfill, I think that will be helpful for everyone. The
Hydrogen,
temperature
I will see that.
classes, yeah, temperature classes, and how to select the electrical equipment if there is a hydrogen gas atmosphere.
Hydrogen gas. 1 minute. If you see the self-set category classes were given, for example, equipment complaints, electrical equipment, for example, category 1 or M1, for example. So the ATEX direct you get directives like 3, 4, or 5 or 9 is given there. So the certification body will certify it. Accordingly, we have to follow. So like this, it's a categorization there. So for each one, so we have to see that one it is intrinsically safe requirement are there or not. So for accordingly,
Okay.
we have to design and manufacture for even hydrogen systems also.
Okay. So got it. So next question is from Senthil Kannan. In what protection technique ingress protections are mandatory? So where do we use this ingress protection techniques? So that is what his question is.
Ingress protection codes are already we discussed. No, first figure, for example, non-protected. So ingress protection codes are there. For example, back of hand solid objects up to 50 or more. So vertically falling water drops will be used as an ingress protection code requirement. For example, it is a code 1 and 1. So this is a second figure protection against water penetration. So we use vertically falling water like that. Different kind of protections are given. So that we have to follow. That is what the guideline says. So what kind of ingress protection is required to be followed?
Okay. So I mean, it completely depends on our
The type of
requirements. We have to understand the
all
requirements
the
and then
everything depends on the kind of categorization that has been given. For example, dust categorization, gas categorization, etc. As we
okay.
discussed in the markings, no. For example, so that is based on that only the design will follow. For example, type of protection
Okay.
required D. It is if you see in the marking, for example, temperature class T1 to T6 and temperature 135 like this is there. So equipment protection level requirements are also there. The kind of equipment category and the environment, for example, is G is for gas or D for dust, and the explosion protection is required. So type of protection required also is mentioned as D. So this is what the 2C is required. Certain area of group it will fall under it, and temperature get T4 was given there. So accordingly, your system design will follow. So this is the equipment when it rating is there. Accordingly, for example, a gas protection, environment protection, explosion protection is required. EX is rated means accordingly the rest of the equipments. For example, a vessel is there, it is designed there. So it's subsequent also will follow that code requirement to prevent that explosion environment in the case as we discussed, the prevention of explosion requirements.
Okay. So next question is from Vikram Raj Tiwari. So in India, ATEX certification and PESO approved, both is required or only PESO?
India ATEX, to my understanding so far, I think ATEX is not adopted. So I guess
I think
PESO maybe
I
then
can
adopted a
answer.
standard. I have to look into it because I was not sure.
Okay, so
Um,
I will answer this question on your behalf if you permit. Vikram Raj
yes,
Tiwari ji, actually in India, if you want to implement any sort of equipments, if you, I mean, see, basically it is very hard for us to find, I mean, explosion-proof equipments because I've been searching for them hell a lot. So I know that the certifications, I mean, manufacturers, whoever is there, they will apply to PESO, okay, to get to give approval for their explosion proof equipments. Okay, so they will submit all the required document and they will get license for their manufactured equipments. So PESO is the authorized body. Actually, it is a governing body who will give authorization for the equipments and we have to use those equipments. So you have every right to ask Indian manufacturer to show their PESO certification and that is enough. As we are still not so deep into implementing ATEX.
thank you, Yogandarji. I learned PESO requirements.
Okay. Right. Next thing is next question is from Atur Mori. The oil and gas drilling rig site is an ATEX. Are all the equipments in the site need to be ATEX certified, similar to oil and gas CPF equipment?
Obviously, oil and gas drilling areas are very, stringent requirements has to be followed. So, equipment as well as ratings are concerned, they have to follow. Apart from that, there is a IOGP guidelines for the rigging side. Very stringent guidelines are there that need to be followed. International Oil and Gas Producers Association guidelines paramount for the drilling sites, for the equipments as well as for the other operations. So they are very important areas, and Ashokji is expert in those. He can add on those things. So because they know how the rigs works, so that will be a very stringent systems to be followed. There is no doubt on that.
So here is the next question from Bhavya. Is there any study with regards to mobile phones being a potent ignition source in hazardous area?
This has been proven. There is no separate studies required. Mobile phones which are not intrinsically safe are prone to create work like an ignition source. It is proven in many incidents, and it has been oil and gas industries. Mobile phones are not allowed basically into the hazard process areas because it is
And
no mobile phone is intrinsically safe. So
yeah,
it's as
and
simple as that.
to add that we used to look for mobile phones which are intrinsically safe and it will cost you a lot of money. We need the polish to buy
I
those
still
mobile.
doubt that's the reality, realistic definition of that intrinsically safe mobile phone. I don't
In
Yeah, they
fact,
are certified.
understand this.
Actually, I do find some mobile phones which are intrinsically safe. I think Caterpillar is providing. If I'm not wrong, there are some companies which are providing.
of
So,
course,
but
they
it
are
is very
providing.
costly.
Yes,
Yes,
yeah, yeah. In
Yeah.
fact, we had a small, 2 years back, we had an explosion and people were using mobile phones, and that was identified as one of the source actually. So, yes, certainly it has to be. Yeah. Go ahead, sir.
And next question is from again Vikram Raj Siwari. Organizations, these are not allowing smartwatches inside the operational area. Are there any chances for fire or spark in this case? Your views on this, please.
any battery powered or battery charged equipments tend to release, irrespective of the amount, these hydrogen related hazards are there. That is one of the reason for preventing any kind of smartwatches or smartphones in any environments. That is the main criteria. It is not about the just the radiation but also the explosion tendency of these batteries used in these things. So mostly they based on their industrial experience, these are been prevented.
Okay. So next question is from Shoaib, Mohammed Shoaib. Is IP66 marking equipment, that is area light, considered as flame-proof, fireproof, or explosion? Oh, okay. See, I don't think, Shoaib, I just want to clarify this one. IP66 is something which speaks about ingress protection. It is nowhere related to flame-proof, fireproof, or explosion-proof. In order to see that, you have to look into the numerics of 6 and 6. Then you'll know the definition. But if it is for flame-proof, fireproof, explosion-proof, again, like Mr. Prakash ji has explained to us, we have to look into the markings, ATEX markings. So ingress protection is something which will not allow the dust ingress or the water ingress into the equipment. I think that will clear the point. So next question is from Raja. So substations which have battery banks generate H2 gas, and it is covered by both H2S sensors and NOVAC fire suppression system. In addition to HAC or API RP505. I mean, is it a question, or you are giving us an information? I just want to clarify once, Mr. Raja. Is it a question, or you are
Yeah,
giving an additional information?
yeah, good evening. Just I want to share some information.
Okay, okay.
I previously worked in Indian based Rajasthan plant where
Okay.
where we used to have substations which have battery banks for UPS purpose. So
Okay.
the huge battery banks, they generate hydrogen gas. So what we had a mitigation measure was providing, NOVAC system, fire suppression system, and in addition to the hazardous area classification and cause and effect diagram.
Yeah.
So in case of any kind of leak from the hydrogen, so it detects and senses and gives the alarm. Subsequently, fire suppression comes into the action and suppress the fire, because there is a possibility of hydrogen, as he said, the beginning, hydrogen has long range of explosive range, lower LDL and UL from 4.5 to 75. So we had that system. But what we did, we followed API RP505 as well for
Oh,
the
okay.
electrical installations in the oil and gas industry.
In
Okay.
substations, apart from the battery banks, just having the hydrogen sensor will not be a solution. Ventilation and exhaust system plays very vital role. And based on my experience, I am telling there is an explosion happened during the battery acid filling, and hydrogen released substantially, and it lead to explosion, and that wall broken in one of the projects that we have been involved in. So the just detection of hydrogen in a battery bank rooms is not adequate. Then the ventilation system has to be designed in such a way that it has to be continuous, and this ventilation should be intrinsically safe, because hydrogen is very volatile and explosive. So that has to be that a ventilation system has to be intrinsically safe system. That is a very mandatory requirement. Now there is an electrical standard, IEC standard has come for this. If I am not wrong, I will go to get into it, and then maybe I will try to elaborate more on it. But this battery banks in substations, hydrogen release is a very major concern. Hence, even the design of the battery rooms now it has been separated in control rooms and substations. Wherever these UPS systems with battery banks were there, they were been completely isolated from the main buildings because of this explosive nature due to hydrogen.
Yeah,
Yeah,
true. But
that
Rajaji,
that's correct.
uh,
It was It
sorry.
was isolated, and that room also isolated, and it had a fire rated door. Only the wall was not fire rated, only the door was fire rated. But still, as a precautionary measure, during the design stage, we had that facility. It's
No,
back
I
in.
just want to understand. I want to understand why H2S sensors is also installed. Is there any chance of toxic, I mean, H2S gas leak near the substation? Just wanted to understand.
No, no,
I mean,
it's hydrogen sensor, not
Acha,
H2S.
it is a
Hydrogen.
hydrogen sensor.
H2,
Okay.
H2, hydrogen.
And one more thing you should understand, if you are installing Novak fire suppression system, and I think my personal experience with the design part is that it works better if it is in an closed area. Like Prakash ji was suggesting a hydrogen gas if liberator has to be ventilated, and that ventilation equipment shall be ATEX rated. So if that is the case, NOAC would be of no use because there is two things. See, here we need to suppress the fire, but here in the case of H2S, it will be an explosion. Instead of fire, we are talking about explosion. But I think it's okay that what you have done. I think we just need to understand your requirements better to.
Let's move forward, Sunny. Yeah.
It's hydrogen gas, not H2S. So, and it's
Okay.
completely isolated area. So just as a, because, and moreover, it's a ketone based suppression system. So that is why it has a less global warming potential. So we had this practice previously, back in 2012. 11 years.
So
Thank you for sharing, Mr. Raj. Yeah.
Next question is from Mr. Senthil. Capso Energy, manufacturing suppliers of explosion proof battery monitoring system for okay. So you're giving us the information. Okay, thank you, Mr. Senthil ji. And Shoaib ji has asked one more question. As we know, mobiles are not allowed in oil and gas plants, but what about petrol pumps as digitalization? So that is a question he has.
Public areas, that is a concern of worry, but there is always, each petrol bunk is marking, switch off your mobile phone, switch off engine. These guidelines are there. So as a responsible public, we need to follow. So that is the one way of, mitigation. So,
Okay, so
Education,
I think
yeah.
we had enough questions. So
we
I
have
think we have answered.
one picture shared by Mr. Singaram. Would you like to ask any question, or you just shared this for the information, Mr. Singaram?
No, just shared the particular oil and gas drilling sites requirement. One of the participants was asking about requirement on EX. So
Very nice.
Definitely there is a requirement.
Yes.
It is certified. So just for the information, I shared this.
Thank you. Thank you so much, sir. You're on the spot.
the tag on the table, equipment, how the tag comes. Yes. Thank you.
Thank you. Excellent.
Thank you.
Yep. Thank you, Mr. Fani, and for nicely conducting the session on the time. And we would like to continue. Thank you, Mr. Prakash ji, for sharing your knowledge as well as patiently answering the questions. And yes, we would like to honor you with our little virtual, certificate of appreciation. Mr. Jito, would you like to briefly talk about Mr. Prakash's presentation?
Mr. Prakash, you made my life worth living. I'm 82-year-old, and listening to your presentation and looking at your slides, it took me back in my late 60s and all of the 70s. I did a lot of research work in the laboratory, not only just for knowing the lower explosive or lower flammable limit, as well as UEL that you were explaining, laboratory work. Then it was also carried out to know the effect on large tanks or columns and all other things, pilot plant scale, as well as extrapolated to the real process plant applications. So you made my day. Not only that, auto ignition temperature, SIT, which is the self-ignition temperatures, hot surfaces, all kinds of things I did with these little fingers, including dealing with the most dangerous, not only the corrosive and flammable and explosive materials, but also presenting in the international conferences, including teaching and training the executives what it really should mean. Just briefly, what you have really presented has a lot of application in various things. And the discussion generated with questions and comments, I can tell you the use of cameras. The last letter I signed for Aramco, which is the largest oil and gas operation, was not to allow any camera, including the smartphones, into the premises of refinery or gas plants. But nowadays, someone's comment I saw, flame-proof cameras. There is a distinction between the flame-proof and intrinsically safe. We lost the sulfur peeling plant from the dust explosion, utilizing wrong things such as what we were talking about. Not only that, we also next door to my plant was the flour mill, another dust explosion. So all the information you have shared has variety of application, and I applaud to you your knowledge, your presentation skills, and I can go on and on and on, and Ashok will be very upset with me that I talk too much. But truly, from the bottom of my heart, you made all that research work applicable to industrial scale and to prevent fire and explosion from many different angles. So hats off to you, sir. Thank you.
Thank you. Thank you, Jit Saab. And with that, we would like to honor our our recognition of our contributors, like our financial donors, as well as our, for J&A, as well as for the J&A Global. We continue their efforts. We appreciate their efforts. These are our ambassadors, I can say, or the subject matter experts who have been sharing their knowledge. And this is our 22nd OKT, and we have enough number of subject matter experts with us, as well as these are the knowledge ambassadors. And we would like to thank everybody, and we would like to everybody to join hands with us in giving back to HSE profession. And we have some of the, as I was telling, that we engage with the corporate organizations. So this is with the Singapore organizations. If you want to if you have interested, you can write to us. Invo Systems is the one who is developing a, this app, a smart sustainability app, where you can, monitor your carbon footprints. We also have a collaboration or MOU with the Center for HSE, where Mr. Funny is instrumental in that. And we also have a MOU with the J&A BHF, as well as a HSE Champ, which we are going to do the, quiz program today. And we also do the monthly global quiz program. These are the winners for the last quiz program, December 2023. And a lot of good participation is there. I'm sure Pravesh is getting ready for honoring with, announcing the another quiz program during the 2024. And this is another program which is coming up, an inception to behavior-based safety for all professionals and managers. Mr. Funny is coordinating this. This will be on 21st January 2023. This will be going to the 3-hour session, which we are scheduling on Sunday for the benefit of our Indian professionals who can really participate in that. It's again, you can also get the e-certificate of participation of whoever is attending full. Again, we encourage everybody who is attending this course to contribute to our foundation in terms of the financial support, as well as the knowledge support. And another important thing which we have worked out is, this is our first outreach and knowledge transfer video podcast. We recorded this almost 4 days back, and we are working on with the quiz program also. This is about 20-minute session and hazards and safe handling of pyrophoric materials. You can attend anytime at your own convenient time. There will be a quiz at the end of this 20-minute session. And if you participate in that quiz, you will get the automatic e-certificate. And we thank Mr. Pravesh for supporting on that. With that, I would like to hand over this to Mr. Pravesh, who is
all of you. Yeah.
Thank you, Jitu Saab, and appreciate your sharing. The record keeping is so good with you. We always talk about 5 years of record keeping, but you kept for almost, 30 plus years of all this information. So it's highly appreciated, and we need to learn from you. Thank you so much, and appreciate everybody. It's already 10 plus in India, so it's time to go to the bed, and look forward for you guys with you guys in future. Again, we have shared so much of information. Kindly support, and let's continue our efforts for safer and healthier workplaces by enhancing our competency levels. You need to be always competent and stand apart from the crowd. With that, I would like to close this call and thank you so much. And we look forward